Hello everyone, today we are going to start lecture 06 of class 8 mathematics chapter number 6, which is squares and square roots. Now in this lecture we are going to talk about various methods available for calculating square roots of numbers. They include methods like division methods, methods to calculate square root of fractions or decimals. But before starting the lecture, I would like to remind you all to learn the squares of natural numbers from 1 to 30. We are at the end of the chapter and we all know the importance of learning the squares of natural numbers from 1 to 30. We have been directly using these squares at various places. If you learn them till 50, it would be very good enough. Okay, but if you learn till 30, it would kind of serve the purpose, and it is necessary. It is not a choice. You should always learn the squares of natural numbers from 1 to 30. Okay, now let us start the lecture by talking about the methods which are available. We have already seen the prime factorization method, which is actually the basic method, but that method applies only when the number is a perfect square. Okay, division method is something which you can apply even if the number is a perfect square or not. Also, this method has a wide applicability. You can use this method to find the square roots in decimals up to 4, 5, 6 or 7 places also. Okay, how many places you want. Also, we will be using this method to calculate the square root of decimal numbers also, right? So this method has an applicability which is greater than prime factorization, since it can cater both non-perfect square numbers. Also it can cater decimals, right? So let us jump to this method and let us see what this method has to offer. So square root of a perfect square by the long division method is basically the square roots in which we use a long division process. Like this method uses long division. This method uses long division process to calculate or to find square roots, right? So since you all know long division process from class 2nd, 3rd onwards, so we have a lot of practice for this particular method. So this method is not very hard. It is very easy method to calculate the square roots. Also, since its applicability is large, this method is a perfect match if you want to calculate the square root in a timely and accurate manner, right? Okay, so the first thing is that division method is the name because it uses long division process. What is the applicability? As I said, when numbers are very large, comma, the method of finding their square roots by factorization becomes lengthy and difficult. We can also call it tedious or time consuming, right? So it becomes lengthy and difficult. So we use long division methods to calculate the square method. Now there are certain steps to use this method, okay, which are actually as follows. But before writing the steps, let me tell you that this particular method is also applicable if the given number is not a perfect square. Okay, so that is also its applicability. So there is no need to write it, but you should always be aware that that is a basic difference. Sometimes it is asked that what is the basic difference. So this is the basic difference in the applicability of these two methods, which is the prime factorization and division, that this method can be applicable to numbers which are not perfect square also, right? So let us talk about the steps which we are to follow to apply this method. So the first step is grouping. Okay, this is the most important step, and generally when we start grouping, the common mistake which students do is they start it from left, but grouping has to start from right, that is from the unit digit, right? Okay, so this is the most important step, that grouping the digits first, or you can say group the digits. Okay, let us write like this, that group the digits in pairs in pairs starting with the digit. Group the digits in pair starting with the digit in the unit place, right? So starting with the digit in unit place, each pair, so you can see you have to start from right. So each pair and the remaining digit, if any, because if you want to pair and there are odd number of digits, there will always be a digit which will remain. So they are together called period. Okay, so basically a pair is called period. Okay, so that was the step number 1. So you have to group the digits. Okay, you have group. Actually, you will later on understand that the number of periods are actually the number of digits in your square root. Suppose after making, there are 6 digits in your number and you make 3 pairs. That is, there are 3 periods. Okay, so you can very well imagine that there will be a 3-digit square root of that particular number. So that is basically the feeling behind it. Okay. I will say that this method is pretty logical and it is very good for calculating the squares. So think of the largest number. Now here comes the long division method. Okay, think of the largest number. You will get a feeling that yes, we are doing long division. Think of the largest number whose square is equal to or just less than the first period. Now obviously the first period will be counted from left, not from right. In grouping we start from right, but the period are counted in the normal fashion, that is from left. Okay, so let us talk about the step number 3. Very easy step. So this is again the long division method, typical long division, that subtract the product of the divisor and the quotient from the first period and bring down the next period. Okay, just like the long division process, nothing extra. Next period to the right of the remainder. And it becomes next period right the remainder, and this becomes the next dividend. Okay, so bring the next period to the right of the remainder and repeat the steps. So this will be the next, or you can say new dividend. Okay, this was the step number 3. Let us talk about the step number 4, which is again the repetition of step 1, nothing new. Okay, but there is a twist in this particular step. Unlike the normal long division process, we will not carry out the same division, but the division would be doubled and something would be left as a blank space, so that we can actually decide that whether that number multiplied that particular digit is less than the new dividend. Okay, so after doubling the division, there is some process which we have to follow to actually carry out the next division. Okay, it is kind of similar to long division, but in a way it is very different also. Okay, so let me write the steps so that I can explain it better. So the step number 4 says that now the new divisor, so there is a rule for division, okay, not for dividend. Now dividend has been just like the long division process. Now the new divisor is obtained. Now the new divisor is obtained by taking 2 times, see, we are doubling the divisor by taking 2 times the divisor, and annexing with it and annexing, or you can say adding with it a suitable, annexing with it a suitable digit which is also suitable digit which is also taken. And how do we decide this digit which is also taken as the next digit of question, right? So that is how we decide, as the next digit of the question comma chosen in such a way that again it follows the basic law that your product should be less than the dividend. Okay, chosen in such a way that the product chosen in such a way that the product of the new divisor and the digit is equal to or just less than the new dividend, right? So you can see that now the new divisor is obtained by taking 2 times the divisor and annexing with that a suitable digit which is also taken as the next digit of the quotient, chosen in such a way that the product of the new divisor and the digit is equal to or just less than the new dividend, right? So repeat these steps till all the periods have been taken up. Now the question will be the square root. Okay, so at last you can say that repeat steps 2, 3 and 4 till all the periods have been taken up, right? Now at that stage, when you have exhausted all the periods, the quotient so obtained is the required square root of the given number. Okay, so you can say that the question which you are getting finally is the required square root of the given number. Now let me explain these steps with the help of a question so it would be easier to digest. Okay, so let us talk about finding the square root of 390625. So it is a 6-digit number. So let us try to find it. Now our first step said that start making pairs. Okay, so we'll start making pairs which are eventually we call periods. So we start with from rightmost side, like from the unit digit. So the rightmost pair would be this, then it would be this. Okay, so pair 25, 06 and 39. So we are getting exactly 3 periods. So we will write like this: 39, 06 and 25. Okay, so we have written the number in the form of 3 pairs. So you can very well imagine that the square root would be anything but a 3-digit number. Okay, it would be anything but you are sure that it would be a 3-digit number. Now second step said that find a number whose square is just less than this first period. So we can see that just less than is 6, because 6 square is less than 39, which is actually 36. So we'll get 3. Now the third step said that you have to bring down this period. So it would be 306, right? So we have seen that from the second step, that actually the square of 36, square of 6, which is 36, is less than 39. Now the third step said to subtract the product from the divisor and the question from the first period and bring down the next period to the right of the remainder. So the next period, that is 06, has been brought down to the right of the remainder. Now the fourth step, which is the most important step, said that double this division. Okay, so doubling with, we will get 6 into 2, that is 12, and leave an empty space here. Now how to fill this empty space? Now it said to think of a number whose product with that particular number, whose product, like if you write 3 here, then multiply 123 by 3 and see if it is less than that or not. Okay, so someday if you choose 8, so if you choose 8 also, then the quotient will also be 8, right? So you have to multiply this. You can very well imagine that 128 into 8 would be very large than 306. Okay, so if you choose 7, then you have to multiply by 7. Similarly, if you choose 6, you have to multiply by 6. So that is the way. Okay, so that is how we are deciding the next digit of quotient. So you can see 123 into 3 would also be large, but 122 into 2 would be just less than 306. Okay, so it would be 244, and after subtracting we will get 2, and carrying 10, then it will get 6. Now we have to bring down the next period, which is 25. Now according to the step number 4, we have to double the divisor, but not complete divisor. Okay, we have to double just this digit. Now this digit 2 double would be 4, 1 2 would be same, right? And again we will leave a blank space. Again I am repeating that the digit which you have chosen here would be double. This 12 now has already been doubled. Okay, so it would be here only. Now suppose someday if it was 8, okay, you can say that, sir, suppose it was 8. Now if you double 16, what you will write? 1 2 1 6? No students, if there is 8, then you have to double. Okay, its double would be 16. 6 would be written here and its 1 would be carried over to the 12, so it would become 13, and you will write like this. Okay, so if there is a number 5 or greater than 5, then its unit digit would be there only, but the tens digit would be add as a carryover to this particular digit number. Okay, 2-digit number, 3-digit number, whatever it is. So that is what we are doing. Now you can very well imagine, since it is ending at 25, the number would be 125, and since you have chosen 5 here, so choose 5 over here also. Okay, so let us represent them with different ways so that you can very well differentiate between the different numbers. Okay, so it would be 5, and you will also get 5 over here. So clearly it is a perfect square, 0. So you can very well see that it is a 3-digit number. Now quotient is the square, so you can see that 390625, its square root would be 625. So that is what we were talking when we were talking about the steps. Okay, so see, the first step was to group the numbers, then we have followed the long division process, but the only difference was that the divisor which we are using was getting doubled, okay, in every step. And there is also a certain way of choosing the number, that if you choose a number 3, then you have to multiply by 3. Similarly, if you choose 4, you have to multiply by 4. Okay, so that is the way. Now let us talk about one more question so that you can actually master the method which we have just discussed. So now it says that find the square root of 16129. Okay, so let us find out. Now you can see there are only 5 digits. So if you start making pairs, 29 would be a pair, 61 would be a pair, but 1 would be left alone. So that is why I was talking about when I was writing the steps, that it might happen that there is a single digit in the first period. Okay, it might happen, and there is no problem. Again, the periods are 3 only. Okay, so this single digit will also be counted as a period. So again the square root would be of 3 digit. Now obviously following the first step, 1 square is 1, so we'll write like this. It would be 0. We'll bring down 61. Now we'll double this 1, so it would be 2. We'll leave an empty space. Okay. Now 24 into 4 would be greater than this. 23 into 3 would be 69. So 22 into 2 would be just sufficient. It would be 44. Okay. Now you will get 17, and then we'll bring down the next period, 7 to 9. Now 2 will remain as it is. This 2 would get doubled, so it would be 4. Now we'll leave the blank. Okay, again. Now 249 into 9 would be very much higher. 248 into it would also be higher. But if we check 247, it is 247. That is nearly 250 into 7. Yes, it would get because 7 into 7 is 49. So I can very well imagine that if I choose 7, so unit digit into 7 would be 49 only, right? So it would end at 9. So 247 into 7, yes. So you can approximate like this also, because you very well know that if you are using this method and it is given square root, then it might be a perfect square, and in that way you can calculate it. It would be 0. So remainder has become 0, so we have to stop over here. So we can very well imagine that square root of 16129 is nothing but 127. Okay, so it was very easy. So this method is again very easy. We'll apply this method for finding the square root of decimals also. Now let us talk about the second method, which is square root by successive subtractions. I have discussed this method a bit when I was talking about the properties of square numbers, that squares are nothing but the sum of first and odd numbers, right? So using this particular property, we can find out the square roots also. Okay. So first of all, we should recall that we know that 1 plus 3 plus 5 plus 7 plus dot 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 plus 2n minus 1 is equals to n square. That is the sum of first and odd natural numbers is n square. Okay, so according to this property, if I add first 6 odd natural numbers, then I should get 6 square, that is 36. Okay, so this is exactly what this property says. So I can write, we have already seen this property, that the sum of first and odd natural numbers is n square. Okay, so now this property can also be used in reverse to actually calculate the square root of perfect square. For example, if you give me 16, what I will do is I will successively subtract first 4 odd natural numbers from it, and if I get 0, then I can say that yes, 16 was 4 square. For example, this is 15. Okay, then I will subtract 3, it would be 12. Then I can subtract 5, it would be 7, and then I will subtract 7 and I will get 0. So what I've subtracted, these are the first 4 odd natural numbers. So I've successively subtracted them from 16 and I got 0. So I can clearly see that 16 is actually 4 square, because in 4 steps of successive subtractions I am getting 0. Similarly, if you do this with 25, you will get 0 in 5 steps. Okay, in the 5th step you will subtracting 9. So you can clearly see that this property can be used in reverse, and you can actually use it to find the square root of perfect squares. But you can clearly see that this property is very time consuming, because so it is suitable only for smaller numbers. Tomorrow if I give you suppose 18 square, and I give you 18 square, this is a perfect square, I know it, and I ask you to find the square root using successive subtraction. So you have to subtract the first 18 odd natural numbers. You can think how lengthy it would be. Okay, so I can write about this property that if we subtract 1, 3, 5, 7, 9 and so on, successively from the given number till we get 0, comma, the number of times the subtraction the subtraction is performed, the number of times the subtraction is performed. Okay, you can write the number of times the subtraction is performed to arrive at 0, comma, is the square root of given number. Okay, so you can clearly see that if we successively subtract first and odd natural numbers from the given number, then in the step we get 0. That will be the final step. So in the number of steps we get 0 would be the square root of that number. For example, if you have 81 and then you have to subtract first 9 odd natural numbers, so it will take 9 steps. Okay, so this was this property. Now let us take an example. Let us find the square root of 64 by successive subtraction method. Now you can very well imagine that this method is only given because yes, it exists, but if you start using it, it would be very lengthy, and you can use it for fun for numbers of square roots of single digit number or even 2-digit number, but it would be very hard to calculate even the square root of 30. So let's say if I give you the square of 35, then you have to subtract 35 odd numbers to find that yes, it was a square of 35, right? And according for learning this method, or in comparison to learn this method, it is very easy to learn the squares of natural numbers from 1 to 30, which I have been asking you to do from since the lecture 01, right? So it would be very easy in comparison to this particular method. Okay, so now 64 minus 1 is equals to 63. Now 63 minus 3 would be 60. We are successively subtracting odd numbers. Then 60 minus the next odd number is 5, which would be 55. Now 55 minus 7, which was the next odd number, is 48. And 48 minus 9 is equals to 39. Similarly, 39 minus 11 is equals to 28. 28 minus 13 is equals to 15, and 15 minus 15 is equals to 0. So we can count the steps. So this was 1, 2, 3, 4, 5, 6, 7, 8. So we can write we have performed subtraction 8 times. So square root of 64 is equals to 8. So this method was that easy, but again it has very limited applicability. Okay, let us talk about the next method, which is square roots of fractions. So to calculate square root of fraction, you have to do nothing. There is just a simple formula which you can use. Okay, for any positive numbers a and b. Okay, you just have to calculate the square root the normal way. You just have to divide them. Okay, positive numbers a and b, comma, we have the first one. If you are given a product, so you can separate them into root a into root b, and you already know how to calculate root a root b using the division method. Similarly, if you are given a fraction a upon b and you are asked to find its square root, then you can separate just them like root a and root b for any positive numbers, and you can calculate root a and root b using the division method and put in this fraction. Okay, so that is basically the square roots of fraction. Let us take up an example to understand it better. So we need to find the square root of 529 841. Now using the formula, square root of 529 upon 841 is equal to square root of 529 whole upon square root of 841, which I know how to calculate, right, using the division method. So let us calculate the square root. Now if you know the square roots of natural numbers from 1 to 30, you would easily calculate it. Okay, so someday if this question comes in the MCQ, you will take actually 5 seconds to solve it. Okay, now see, it will take time to calculate. So let us use the division method. Okay, now to calculate square root of 529, we will make pairs. So 29 would be a pair and 5 would be the second pair. Now there is only one number, that is 2, whose square is just less than 5. Then we will bring down 129. We will double 2, it would be 4. Now we can very well see that 43 into 3 would fit here, and it would be 129. So you can see root 529, which implies that root 529 is equals to 23. Okay. Similarly, let us calculate the square root of 841. Again, making the pair 41 will be the first pair, and then 8 will be the second pair. Now again, 2 square is just less than 8. Okay, so it would be 4, 4, 1, and then we'll double 2 and we'll leave an empty space. Now you can clearly see that it would be filled by 9 because 49 into 9 would be 441, right? So it has become 0. So this has given that root, not 529, root 841. Okay, so root 841 is actually 29. So if you want to calculate it now, you can calculate. Implies that under root of 529 upon 841 from equation 1 would be root 529, that is 23, upon root 841, that is 29. So that is the answer. Okay, so you can leave the answer over here. So you can see that it has become very easy to calculate the square root of fraction using this particular formula. Okay, let us take up another question. Find the value of root 3 by 7 up to 4 decimal places. Very good question. Okay, now to calculate this, first of all we have to calculate root 3 and root 7. You might be imagining, then we have to divide them, but it would be very tedious. So instead of doing that, let us actually kind of rationalize it so that we have to calculate only one root. Okay, so let us do that. Now we need to find root 3 upon root 7. Okay, so if I do a little improvisation inside and multiply and divide by 7, actually I am multiplying and dividing by root 7, you can very well imagine, then what I will get is 21 upon 49, right? Now if I separate it, so it will be root 21 upon root 49, and which will be eventually root 21 upon 7. So now see, root 3 by 7 which I have to calculate is just root 21 upon 7. So I have to calculate only one root, and I will calculate it to 4 decimal places, and then I will divide by 7. It would be very easier than to find root 3, root 7 separately and then dividing each other, because obviously both 3 and 7 are not perfect squares, so they will come in decimals. It would become very tedious to divide a decimal number with another decimal, and that too to the accuracy of 4 decimal places. It would get a lot of time. Okay, so after doing this, we just have to reduce the quotient to calculate the root 21. Okay, let us do that. It is also time consuming, but it would be again easier than what we would have done. Okay, so let us talk about 21. So since 21 is 21, so there would be no pairs, or this is only one pair. Now let me give you a kind of idea of how we'll solve decimal numbers. Now since we need 4 decimal places and 21 will not be suitable for that, so we will put a decimal over here and we start adding zeros, but only in even numbers, right? You cannot add zeros in odd numbers. Since we need 4 decimal places, so we'll need 4 zeros, and these bars will represent pairs. Okay, so we have paired them. So we have put zeros, either put 2, 4, 6 or 8 zeros. You cannot put 3, 5 or 7 zeros. Okay, since pairing is done from the rightmost side. Okay, so now we'll start following the simple procedure. We'll ignore the decimal and we'll just bring down the periods as we did in the other case. So square of 4 is the only one which is less than 21, so it will be 16, and we will get 5. Now since we are bringing period of our decimal number, put a decimal. Obviously you know that root 25 is 5 and root 16 is 4, so root 21 would be something 4 point something, so put a decimal. Now there is no use of this decimal. Use these zeros and pairs just like normal numbers. Okay, now we'll double 4, so it would become 8, and we'll leave a space over here. Now we can clearly see that 85 into 5 would be something which would fit over here, and it will give us 425, which will leave us with 75, and we'll bring another pair, and after doubling 5 it would be 0 because the double of 5 is 10, and we will add 1 over here, so it would become 9, right? Now we'll again leave a mark. Now 90, so 900 would be 9 into 8 would be 72. Yes, so 908 into 8 would be just less than this, and calculating 900 into 8, 72, and 8, 64, so it would be 7264, right? So this fast your calculation should be. So it will leave us with 236. We'll bring down next pair. Now we'll double 8 would be 16, so 6 over here, 1 would be added here, 9 would be here, and this will be left behind. Okay, then 9, it would be 9,000 something if I use this digit, and it is 23,000, so it would be twice. Okay, so I can very well imagine that it would go twice. So we will leave with 18324. Finally we will have 527600. Right, now we can take them here since the space is less. So 527600 would be here. Okay, then we'll double 2, so it would be 4. So this would be here, and we leave this with this number. Okay, so now we can clearly say that it is 5,27,000. It is 91,000 something, so it will go with 5. Okay, yes, 5 times. So we will have 458,225 as a number, and then we'll get 69,375 as the remainder. Now obviously you can pursue further, but we have already got 4 decimal places using these questions. So you can put a line like this so that you can know, and this has been taken over here. Okay, so you can very well see that we have got 4 decimal places. So now we can write root 21 upon 7 as 4.5825 whole upon 7, and it would be easier. So finally, which implies that root of 3 upon 7 would be, it came out to be 0.6546. So we can write here that root 3 by 7 would be 0.6546. Okay, so this was again very easy to calculate just because of the division method. So it has a very wide applicability. Now let us talk about the last method, which is square root of numbers in the decimal form. Okay, it is nothing, it is very easy. It just says that put the number of zeros in pairs. Okay, so it says that make the number of decimal places. It says that make the number of decimal places even by affixing a 0 if necessary. Now obviously if after decimal you have odd number of digits, then yes, you have to affix a 0. Okay, then now mark periods. Now there is a little change. For the integral part, the period will be marked similarly from the rightmost side, but from the decimal they would start from the leftmost side. Okay, so now mark periods and find out the square root by the log division method. Right, also put the decimal. Actually we have already kind of used half of these things in the previous question, so it would be now become easier. Put the decimal point in the square root. Put the decimal point in the square root as soon as the integral part is exhausted. Right, so put the decimal point in the square root as we have done like this. As soon as 21 was exhausted, we have put a decimal in the question part. Right, so these are the steps. Now let us talk about some questions and find out the square root of 176.25 to 176. You can clearly see after decimal there are 6 digits, so no need to fix any kind of 0 over here. So let us just find the solution, find the square root. So using the long division method, we will write like this. 76 is a pair, 21 is a pair, 25 is a pair. We have started from the left and here we start from the right. So again 76 is a pair and 1 will be left alone as a pair. Okay, so you can use commas and these bars both, but bars are preferable because comma kinds of give you the feeling that they are separated. Okay. So obviously 1 square would be less than 1, so we have exhausted the first period. We have brought down the second period. Now 1 double would be 2 and here would be a blank space. So 23 into 3 would be 69. Now we have exhausted the second pair also. Second period we have brought 7. Now if you have to bring this pair, you can bring it down, but since the integral part is exhausted, you have to put point. Also you can very well imagine that the number is 176 point something. Now 169 and its square root is 13 and 196 square root is 14. So obviously 176 is approximated somewhere between 13 and 14. So you cannot do a mistake over here, right? It is very easy to check your answer. Now 3 double would be 6. So 2 would be as it is and we will have a blank space. So obviously 262 would be just less than 725, which would be 524. Subtracting them we will get 102. Then we'll bring down the next period, which is 21, and then doubling this we will be 264 and we'll leave a blank, and it would be 7 times. Okay, so we will get 18529, right? Subtracting them we will get 1592 and we'll bring down the last period, which is 76. We will double it, so 7 double would be 14, so 4 would be here, 1 would be add over here, so it would be 5 and 26 would be as it is. We'll leave a blank over here and the last digit is 6, so it is 1,59,000, it is 26,000 something, so it would, yes, it would go 6 times and it would be 6 into 6, 36, 6, it would be 7, then do add, it would be 2, it would be 9, yes, it is getting exactly, so we are getting nothing, we are getting 0. So you can very well see that square root of 176.252176 is equals to 13.276. Okay, let me tell you one more thing over here, that since you are reading it 176, after decimal you do not read like this, it is 176.252,176. No, after the decimal the digits are read as individual digits, like 176.252176. Similarly here it is not 13.276, it would be 13.276. okay, so that is the rule to how to read a decimal numbers, right? So this was all about this particular lecture in which we talked about various methods of discussing square roots. Okay, I hope you enjoyed the lecture and you got to know different methods available, and you get to enjoy the division method, which is actually the most crucial. Even it is important than the prime factorization method. Okay, so I hope you all got my lecture. We'll meet in the next lecture. Till then, goodbye.